let's go. Radius, half the diameter. Diameter is twice the radius. Have you guys ever heard of this term before? Chord. That's not a diameter. Why is it not a diameter? Doesn't go through the center, all right? But the endpoints are still on the circle, all right? Endpoints on the circle, but doesn't go through the center. That's a chord. Now, here's a question for you. Could I consider a diameter a chord? Is a diameter a type of chord? Are its endpoints on the circle? So the answer is yes, including, and I need you to jot this down, the diameter is the longest chord in a circle. Longest chord in a circle is called the diameter. You will not find any chord longer than the diameter. Last thing before I go on, how do you name it? Like a triangle I could name by its vertices, A, B, C. How do you name a circle? By its center. So the name of this circle, circle C. Circle C. And you guys may, and you can use this too, you're going to start seeing this abbreviation now. Very lazy, but circle C. You're going to see that a lot in your textbook. Okay? So again, you name a circle by its center. All good there? Okay. Let's get to this whole circumference business here in a second. Let me open it up to you guys. Do you think two circles can be congruent? Well, let me do this. Are all circles congruent? No, because what's congruent mean? Same size, same shape, and not all circles are the same size. So what would make two circles congruent then? Go ahead, Saad. I can even go shorter than that. The radius, yes. Two circles are congruent if their radii are congruent. And radii, that's the plural for radius. We don't say radiuses, radii. All right, if the radii are congruent. When do you think they're similar? What's similar, Madeline? Okay, let's keep building on that, because that is correct. If I take two circles and I give you the length of the radii, aren't they already in proportion? Right? So what am I trying to tell you guys? All circles are similar. Yes. Good stop back there. Good. All circles are similar. All circles are similar. Concentric circles, you guys want to tell me some everyday objects that are concentric circles? Circles that share the same center? And I could do more too, if I wanted to. Let's go, let's roll. What do you got for me, Nate? Frisbee, okay, yep. As long as I have those lines in there, right? Yep. All right, let's keep rolling. There's more. More to life. What do you got, Madeline? Donut, absolutely. Number one on the list. Dartboard right back there. Concentric circles. Julie. CD. Yep. Especially with the lines on it. The tire. I think you guys got them all here that I had. All right. Concentric circles. Circles that share the same center. Okay. All right. We've talked about these in the past. I just want to bring it up again. When we say anything, a circle or any polygon is inscribed. Inscribed sounds like inside, all right? So if I'm told any polygon, any circle is inscribed, I know that figure is inside something else. All right, that figure will be inside something else. What if the figure's on the outside? We've talked about this a little bit too in triangles. That we say if it's on the outside, it's circumscribed. If it's on the outside. Okay. guys feeling all right today? It's a long haul now, huh? One day off. It's a long haul, huh? Good talk. Can you find the perimeter of a circle? Well, perimeter is what? All sides added up. Problem with the circle? No sides. So I can't find the perimeter, so we change the word to circumference. Okay, circumference is another name for the perimeter of the circle, the distance around my circle. And there's two formulas, none of which I'm going to give you, I'm sorry. All right, you can choose C equals pi d, d standing for diameter length, and C equals 2 pi r, and r would be the radius length. Guys, you choose what you want to use. I don't care. All right, here you go, my dry sense of humor here. If you want C equals pi d, coffee pie donuts. Anybody? Coffee pie donuts? Oh, I got another one, Carolyn. Cherry pies are delicious. Because there's actually another part to that saying, cherry pies are delicious. Anybody know the rest? For area of a circle? Apple pies are too. Okay. So again, however you want to remember circumference. Just trying to help you guys out. What are they called? Mnemonic devices? Is that what they're called? All right, so let's go. Pretty basic one for number one. I gave you the radius, find the circumference. But I just want to make sure we're good here on the directions. Leave your answer in terms of pi, meaning when you go to do some calculations, you don't hit the pi button. I want that pi in your answer. Okay, so do not go to the pi button on your calculator. Keep the pi right where it is. So let's help me out here. I'm going to use 2 pi r here because I'm given the radius. But again, you guys want to use pi d, whatever floats your darn boat. 13, want to help me out here? What's the radius? 16, I multiply it by 2, and I end up with? What are you doing? 32. Now, do you guys write x6 or 6x? 6x, right? So guess what? I'm going to write 32 pi. All right, 32 pi. Leave in terms of pi. There's a pi in your answer. Okay. All right, find the diameter and radius when I give you the circumference now. I'm giving you the circumference. And because we are honors, I'm going to show you a little something here using both formulas. We're going to get the same answer, but I want to just make sure you guys don't fall into a little trap here. What is given in the problem? Here you go, 14. What's given in the problem? Circumference. So I'm going to plug that in for C. 106.4 equals pi d. How do I get the diameter all by itself now? Diameter all by itself, 27. Diameter all by itself? Well, it's being multiplied, though. Calm down. Divide both sides by pi. Yep. Divide both sides by pi. So d will be equal to... This is what happens when I get fired up. I lose the packet. What do you got there, Braden? Let's turn that sucker on. Hundredth. 87. I want to tag something with it. Millimeters. No, don't even say it. That's area. Area is square units. Yep. Okay, now a point right here. Radius. I am not going to divide that diameter by 2 because that's a rounded answer. I'm going to go back to my calculator, whatever 33.87 had on the calculator, and divide that by 2. That will be a more exact answer. All right, so I'm not going to divide the diameter by 2. I'm going to divide the full decimal by 2. And when you go back and do that, what do we end up nearest hundredth? Here you go, 12. 16.93 millimeters. please don't go ahead. I want to show you something. If you chose to do c equals 2 pi r instead. So 106.4 equals 2 pi r. How would you solve for r in this case? Six, how would you solve for r? Okay. Everyone, take a look at my calculator right now. Oh, there it is. 106.24, 106.4 divided by 2 pi. That's what I ended up with. But was that the radius length? No, right? It was 16.93, what Frank gave us. Why, though? Anybody know why this gave me an incorrect radius? When I put it in my calculator like this versus maybe using my fraction template? What do you got there? That's it. It follows order of operations. It took 106.4 divided by 2, then multiplies by pi. So what I'm trying to tell you guys is, if you ever divide by 2 pi, use your fraction template, or do what to 2 pi if I wrote it like this? Parentheses. Put the darn thing in parentheses. Okay? Good. Never just divide by 2 pi. Put it in parentheses, or I've been begging you all year long, use your darn fraction template. Okay, everyone see what happens there? All good? Okay. Ooh, nice. A square with a side length of 9 inches is inscribed in circle J. Exact circumference. First, directions, exact. No decimals in your answer. None. None. I don't care if it's 0.5, 0.6. No decimals in your answer. And no rounding either. So how the heck are we going to leave this? We'll find out. Okay, 4? Who's got 4? It says the square is inscribed. So is it inside or outside the circle? Inside. So let me grab a circle here. Put a square inside that sucker. And when it's inscribed, the vertex, all 4 vertices are touching the circle. It's just not floating in there. And one more question before we start. 8, where's 8? 8, not here, perfect. How about 7? 7 here. Circle J, what's that tell me, Evan? Circle J, I call it circle J. Nine, what circumference formula do you want to use? Because it's asking me for circumference, so I got to use one of the formulas I've given you. Pi d or 2 pi r here. Okay, pi d. So you guys are telling me the only thing you need is diameter, right? If you can find the diameter of this circle. All right, well, multiple ways I could draw the diameter. I could draw in this diameter. I don't know how helpful that's going to be, finding that one. What I'm trying to get at is, can anybody find a diameter that maybe I could find with all this info? Madeline, let's roll. Why not? Here you go, everyone. Diagonal of the square. Let's find that diagonal. Let's find that diagonal. And we already know the sides are 9 and 9. Let's talk here. What's your way of getting me that diagonal? Because I'm probably not going to use it. Andrew? Pythag. That's one way. You could do 9 squared plus 9 squared equals c squared and try to break down that radical. All right, I'm going to do it a little quicker. And I'm going to try to pry it out of you guys. Another way I could find it other than using Pythag. Oh, you the man, Nate. This is an isosceles right triangle, right? So what are these two angles here? 45, 45, right? Oh, when are we doing that? Just do Pythag. All right, go ahead. I don't care. I'm not going to fight you. Nate, which side did I give you? Across from the? Watch how quick this goes. 9, 9. What's my diagonal?
9 times the square root.
You guys did Pythag. What'd you get? The square root of 162? If you broke that down into 81 and 2, you would have got 9 radical 2. Okay? So let's go back. Circumference now. No decimals, right? So what am I going to plug in for my diameter? Diameter length? 9 radical 2. I'm just going to clean that up a little bit because I always like the pi over to the right. So 9 radical 2 pi. Any decimals in my answer? Nope, but I am missing one thing. Units. Questions on that one? It's not easy. I know it's not easy. Okay, I'm going to kind of leave the next two up to you and your group. So I'll start you with this next one here because I want you to get a visual of what's happening. The center of circle Q has coordinates 3, -2. I graphed that just so you guys, I know there's no graph on yours, but just so you can see it up here. And the circle goes through 7, 1. What's the length of the diameter? So let me show you what this circle looks like. This is the best use of the compass all year. There's the circle. Here's Q, here's R, but I'm looking for the length of the diameter. Talk it over with people around you if you'd like. And then once you think you have that one, go on to the next one. I'll give you guys 5 minutes and we'll talk about it as a class. All right, so right now you know Q and R. You know Q and R. Now you got to find the diameter. And once you do that, see if you can do number 5. You approach number 4. 17, how'd you approach this?
So I found the distance between the coordinates.
Q and R?
Yeah.
Okay, so you found the distance of QR, and what'd you find? Yeah, so the distance of that is 5. I'm listening.
And then I multiplied it by 2.
Yep, so the diameter, 5 times 2, 10 units. Nice job. Okay, any issues there? And then very kind of similar. I gave the endpoints of the diameter here, and now I'm looking for the circumference. So walk me through this. 16, walk me through this.
I found the distance between the 2 points,
Which was the diameter, yep. And what was the distance?
10.
10. Can I, before Andrew goes on, can I ask, did anybody not use the distance formula? Anybody see how you don't have to use it? 2, 2, and 2, 12. They both had the same x coordinate. So basically they're right on top of each other. Just throwing that out there too. So a distance of 10. Still listening, Andrew.
And then in terms of pi, it would be c equals 10 pi.
And I meant to ask you this before when your number came up. Your flow game is strong with that hair lately. It's pretty. That flow is pretty good. What happened? Is it in a hat, or you doing it that way, or was it that long to begin with? I didn't really notice. Usually I notice when it becomes like a bird's nest, but like I can tell Jack got his hair cut because I don't see any woodland animals popping out. I'll tell him next period. But your flow game's pretty strong. It was real strong yesterday. Blew me away. Looked like it was in a hat for a while. So, questions? Anything else? You're still strong back there, Skylar. Don't worry. Okay. Any questions, guys? All right. Please check your answers on Aspen.